Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing a numerical on cantilever beam, how to find the shear force and bending moment, and also how to draw the shear force and bending moment for a cantilever beam when it is subjected to the concentrated load. So here I have a cantilever beam of length equal to 2 meters carrying a point loads which is as shown in the figure. So there are 3 point loads here, that is 300, 500 and 800 Newton, and apart to of 0.5 meter from A, 0.7 meter from B and 0.8 meter from C. Now we are supposed to find out what is the shear force and bending moment for the respective points. Now, first and foremost thing is that we are supposed to calculate what is the shear force at each and every point. So, starting from point D, I just start from the right hand side. So, starting from point D, so shear force calculation. So, at point D. At point D, shear force calculation at point D. Now, exactly at point D, we have only one force here, that is 800 Newton. So, which is acting in the downward direction. So, as per our sign convention, so right side force which is acting in the downward direction, it is considered to be as positive. So, the shear force at point D is plus 800 Newton. Plus 800 Newton. So next at point C. So at point C, as we know that shear force is nothing but it is the algebraic sum of all the forces either towards left side or right side of the beam. So it is at point C. Prior to the point C, we have point D. So therefore, at point C, we have the effect of the force acting at point D also, apart from the 500 Newton which is acting at point C. So therefore, shear force at point C is nothing but 500 plus 800. That is nothing but the force exactly acting on that point plus the force at the previous point we are supposed to consider. So since we are taking from right hand side direction, so it is considered as positive. Right side, the force which is acting in the downward direction is considered to be as positive. So it is plus 800 plus 500. So it comes on to be 1300 kilonewton. So sorry, 1300 Newton. So this is the amount of shear force which is acting at point C. Now at point B. So exactly at point B, we in order to calculate the shear force at point B, so we have 2 points prior to point B, that is C and D. So in order to calculate the shear force at point B, it is the effect at point B plus the effect of point C and point D, the force effect due to point C and point D. So we are supposed to add all the three forces, that is 300 plus 800 plus 500. So it is equal to plus 300 plus 500 plus 800 Newton. So it is nothing but 1600 Newton. So therefore the total force acting at point D is 1600 Newton in the positive value, because we are taking from the right hand side direction. So right hand side downward direction force is considered to be as positive. Next at point A, so we don't have any other force exactly acting on point A, but as we know that the shear force calculation is nothing but the force acting on that point plus the previous points we are taking into consideration. So the force acting at point A is 0, but we have other three forces which is acting prior to the point A. So therefore we are going to consider the effect of the 3 points, that is B, C and D. So therefore the shear force at point A will be exactly equal to the shear force which is acting at point B, since there is no load which is acting at point A. So it is plus 1600 newtons. So this is about the shear force calculation. Next, coming on to the next step, that is calculation of the bending moment. So bending moment calculation. So in the bending moment calculation, we have bending moment calculation. So here exactly at point D, so we have prior to point D we don't have any point, as we know that moment is nothing but force into perpendicular distance. So while calculating the bending moment, we are supposed to consider the previous point, not the force acting at that point. So therefore previous to the point D we don't have any other force. So therefore bending moment at point D is equal to 0. Next, at point C, so exactly at point C we have only one point prior to point C, that is point D. So at D we have 800 newtons. So force into this distance, perpendicular distance, so 800 multiplied by 0.8, so it is 800 into 0.8. Go along the force through the line of action, that is go along the force through the line of action. So it is a clockwise variation. So 800 multiplied by 0.8. Since it is a clockwise variation, we are going to take it from the right hand side of the beam. So as per our sign convention, so right hand side with the clockwise movement is considered to be as negative variation. So therefore it is considered to be as minus. So it is minus 640 Newton meter. So 800 it is in Newton, 0.8 it is in meter, so it is 640 Newton meter. So next is at point B. So at point B we have previous points. So we are going to consider the effect of forces acting at C and D. So that is starting from D we have force acting at D is 800, per distance between D to B it is 0.7 plus 0.8, it is 1.5 meters. So 800 into 1.5, then 500 into 0.7. So therefore the total force total moment acting at point B is 800 into 1.5. This 1.5 is nothing but the addition of the distance 0.7 and 0.8, and then 500 into 0.7. Since go along the force through the line of action, so it is both are clockwise values, so it is considered to be as negative. So therefore the total force total moment at point B is equal to 1550 Newton meter. So this is all about the moment at point B. So next at point A, you have at point A you have priorly there are 2 points, that is point B, C and D. So all these 3 force moment are to be considered while calculating the moment at point A. So that is nothing but starting from point D, that is 800 into the total distance, that is 1.5 plus 0.5, that is 2 meters. 800 into 2, 500 into 1.2, 300 into 0.5. So this is the total moment which is acting. So 800 into 2 and then 500 into 1.2 and then 300 into 0.5. So it is all the three are acting in the clockwise direction. All the three are considered to be as negative. So 2350 Newton meter. So this is all about the calculation of bending moment at points at the respective points. So now drawing the shear force and bending moment diagram. So coming on to the shear force drawing, first we are supposed to project the lines. We are supposed to project the points. Okay, so and then after projecting the points, we are supposed to draw the baseline like this. So this is the baseline wherein the points which are the positive value will be plotted above the baseline, and the points which are of the negative variation will be plotted below the baseline. So since this is the concentrated load, so therefore the shear force for the concentrated load will be of the stepped variation. So exactly at point D we have 800 with a positive variation. So it is plus 800. This is 800 Newton. So next exactly at point C we have 1300. So this is 1300, and then at point B we have 1600, and at point A we have 1600. So this is at 800. As I said, this is a stepped variation. So just draw the straight line and then a step exactly at 1300, and draw the straight line and a step at exactly at 1600, and just draw a straight line. So this is 1600, 1600, 1300 and 800. So this is a positive variation SFD. So this is the shear force diagram for the given force. So next is bending moment diagram. So as I said that we need to draw the baseline first. So which all the values which are positive will be drawn above the baseline, and which are the values which are negative which is drawn below the baseline. So at point D I have 0. So exactly it will be coinciding on the baseline itself. So at point C I have 640 with a negative value. So this is somewhere here below, and then mark it as 640. And then exactly at point B I have 1550. So 1550, which is still more below. And then exactly at point A I have 2350. So these bending moment variation, as in case of the concentrated load, it will be of the linear variation. So just you need to join this with the straight line. So this is the linear variation. So mark here 2350, 1550, 640 and 0 with a negative variation BMD. So I just repeated the variation for the concentrated load, as in case of bending, as in case of shear force, the variation as in will be stepped, and whenever it is bending moment, the variation is linear. Thank you for watching. Please like, share and subscribe the video. Thank you.